grade 10s, you had some homework for today. I want to mark. The first was exercise 2 on page 107. They start off and they ask, nee, kom maar opgesels. They ask us which distance time graph represents the motion of an object moving at constant speed. If you have constant speed, your distance time graph would look like that. So which one would be the correct answer? It would be D. Number 2, at a sports event, a champion runner and a car take part in a race. The runner runs at a constant speed of 10 meters per second. So it's constant speed of 10 meters per second from the start of the race. Then it says during the first 5 seconds of the race, the car's speed increases from 0 meters per second to 25 meters per second, and it took 5 seconds to do that. On the graph, draw a graph to show the motion of the runner. Well, a runner and a car. Okay, so the motion of the car, they give you the graph grid. They've got 10, 20, 30. And over here we've got 1, 2, 3, 4, 5, 6, 7. All right, so the motion of the car, they say the runner runs at a constant speed of 10 meters per second from the start of the race. During the first 5 seconds of the race, the car's speed increases from 0. Well, for the first 5 seconds, we have 1, 2, 3, 4, 5, 6, 7. And the speed on the y-axis is 10, 20, 30. So for the next 5 seconds, this car is going to accelerate from a speed of 0 to reach a speed of 25 meters per second. So over there, and over there, that would be the spot. You would draw a straight line with your ruler. That's the first 5 seconds. Okay, the motion of the runner, I say he runs at 10 meters per second from the start of the race. So the runner goes there. Are you with me? All right. Now they say, well, okay, use a pen of different color for the second graph. Are you with me? This was the runner, and that was the car. Okay, number 3. The graph shows how the distance traveled by a vehicle changes with time. Which row describes the speed of the vehicle in each section? Just quickly want to draw it over here. We have that, that, and that, and this is a distance time graph. Yeah, I've done both. Okay. We have P, Q, R, and S. So, how would you describe the motion without looking at the table that they give you? As the distance increases as the time goes by, we say he is running with a constant speed, all right? From P to Q, he had a constant speed, and then 0 speed because his distance doesn't change. Then he stood still between Q and R. Yes, and then? So? He went backwards, yes. No, do you understand that? Page 108. So, it would be constant speed, 0, and decreasing. It's also constant speed, but it's just going in the back direction. Because that's constant. That's just negative. Okay. So the answer would be A. Say again. You would have an exponential curve. Remember, this is a distance time. Dit is waar jy iets op velocity time dink ek. Okay. Ja. Nou, this, luister gou. You have a displacement time graph, distance. So if your distance increases as the time goes by, but your distance increases with a uniform amount, then you have got a constant speed. Remember, if we go back to our graphs, just have a look there. Where are the shapes? Over here. Distance time graphs. There. For constant velocity. What? No, forget about the angle. No, the angle has just got to do with how fast it's going. If it's got a steeper gradient, it's going faster. If it's got a shallower gradient, it's going slower. But it's constant velocity. Okay. Now, where was I last? All right. Then you had to do the check your progress part. Is that right? Yes. Question 1. People, when you do these questions, you need to read very carefully to know whether you are working with constant velocity or constant acceleration. And you need to be careful when you look at the graph to know whether it is a displacement time or a velocity time graph. Do you follow? Okay, so briefly explain the differences between the following pairs of terms. Speed and velocity. Speed is a scalar, velocity is a vector. They refer to rate of change of distance for speed and rate of change of displacement for velocity. Instantaneous velocity and average velocity. Instantaneous velocity is the velocity at a specific instant in time. So it's the rate of change of displacement for a specific instant in time. All right, just a split second. Average velocity is the average velocity of the path. You will add up the different velocities, starting velocity, final velocity, and divide it by 2. All right. Positive and negative velocity. Positive velocity, for example, object traveling away from you. Negative velocity would then be object traveling towards you. Okay. The plus and the minus indicate direction, away from you or to you. And it doesn't matter. I could have said the one going away from me is negative and the one coming to me is positive. It's relative. Okay. Number 2, for each of the following motions, determine the distance covered. A cricket ball traveling at 36 meters per second for a time of 10 seconds. All right, so the distance, we know speed or velocity is distance divided by time. So distance is speed times time. So what's the speed? 36. What's the time? 10. What's the answer? 360 meters. Whose is right? No, you should get that right. Okay. B. A motor vehicle traveling at 120 kilometers per hour for 6 hours. It's the same calculation, except we're working with kilometers and hours. If this one was in minutes or seconds, you would have to convert it to hours. All right. So once again, we want to get the distance it is velocity times time. So it's 120 times 6 is equal to 720 meters. Any questions there? Kilometers, thank you. Yes, somebody is awake. Jan Ivan. Goodness me. All right. C. A jet aircraft traveling at 900 kilometers per hour for 120 seconds. Now we have an example. One traveling at 900 kilometers per hour for how many? 120 seconds. So you have to go and convert that to hours. All right? So it would be 120 divided by 60 will give me 2. That would be minutes. To get hours, we would take 2 minutes divided by 60 will give me how much? What is the value? Yeah. Okay, so now you can go to the formula where distance is speed times time. The speed is 900, the time 0.03, and that gives you an answer of? Is it right? Okay, 30 kilometers. Yeah. Yeah, be very careful when you do that. You are supposed to put the value into the memory of the calculator. You only round the final answer. You don't round off on your steps. Okay? Because then the answer will become totally inaccurate. All right. Now, the next question. Draw a velocity time graph. Velocity time graph for a car moving with uniform acceleration from 10 meters per second to 20 meters per second. So 10, 20, 30, 40. And the time interval is in seconds. 1, 2, 3, 4, 5, 6, etc. So uniform acceleration from 10 meters per second to 20 meters per second in 4 seconds. 1, 2, 3, 4. There. Why did my graph not start down on the 0 point? Well, they told us that it starts at 10 meters per second. Who made a mistake there? Okay. Then they say, the car then moves with uniform velocity for another 4 seconds. So 6, 7, 8, 1, 2, 3, 4 seconds. So there's the 4 seconds. It's got to move with uniform velocity there. Okay? And lastly, they say the brakes are applied and the car comes to rest in 2 seconds. 9, 10. So there's 2 seconds. So within 2 seconds, it goes from there to there. So that's what the graph will look like. Okay? Yeah. No. No. Say again? Yeah? Yeah. Yeah, but it's going down. No, because it's constant deceleration. Only the deceleration changes is the curve. Okay. All right, now they say, use the graph to find the value of the acceleration for each part of the graph. In other words, what is the acceleration there on that blue line? And what is the acceleration there on the green line? Why do I draw an angle like that? Why have I drawn this black line like this? What must I work out? The gradient of the line. Okay, so you can either use the whole line, it won't really matter. So if we use the whole line, the change in y over here is 20 minus 10. Okay, so for the blue part, the change in velocity is 10 over change in time is 4. So the acceleration is 2.5 meters per second squared. And it's positive. All right? When we go and look at the deceleration part, we can figure out the gradient of the line. I can use the whole part. So now the change in velocity is 20. And the change in time is 2 seconds, which gives me 10 meters per second squared. But what do I know about this one? You must either indicate it as being negative, or you must say it is? Yes, decelerate or retarding. No. All right. Number 4. Any questions there? Okay, Armand, het is goed as jy verstaan. Okay, number 4. A car starts from rest and accelerates for 2 meters per second, at 2 meters per second for 6 seconds. It then moves at uniform speed for another 8 and finally decelerates at 4 meters per second until it stops. Draw the speed time graph, right? Draw the axes. This is speed, time. People remember the proper protocol when you draw graphs in tests and exams. You need to label the axis, speed or velocity, and you need to indicate the unit. Okay? You need to name the graph, speed versus time. Okay? Choose a correct scale. Okay, so let's go and do the following. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many do I need? 10. 11, 12, 13, 14, 15, 16, 17. All right? And going up, I need 1. How many? Okay, let's take that. 4, 8. Come on. 12. 16, to where must it go? 16 is enough. Okay. They say a car starts from rest. There's the 0. Okay. So he starts from rest and he accelerates at 2 meters per second for 6 seconds. Now, 1, 2, 3, 4, 5, 6 seconds. Yeah. No. How are you going to figure out what his final speed is going to be? Well, now you have to work the back way around, because they say he accelerates at 2 meters per second. So change in y over change in x is equal to 2. We don't have that one, but we do have that one. So what over 6 is going to equal 2? 12. So the change in velocity starts from rest must be 12. Did you follow me? Who didn't follow? Okay. So there goes the first part. Who had that right? Good. Well done. Okay. All right. From that point on, they say it then moves at uniform speed for another 8 seconds. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 8 seconds will be 1, 2, 3, 4, 5, 6, 7, 8 seconds. So he must have constant velocity for 8 seconds. Follow me. All right? And finally, he will decelerate at 4 meters per second until he stops. Now, we have to do the same thing. Change in y over change in x must equal 4. Now, we don't have the y, but we do, no, we don't have the x, but we do have the y. All right. So what is the change in y? It's from 12 to 0. So change in y is 12. We don't know what change in x is, but it must equal 4. So 12 divided by 3. 1, 2, 3 seconds. There it goes. Etium. Say again. Because they said, they gave it to us. He decelerates at 4 meters per second. All right. Now, B. What is the maximum speed of the car? 12 meters per second. For how long was the car traveling in terms of time? 17 seconds. What else could they have asked? What distance did it travel? Let's quickly work out the distance. They didn't ask it, but let's work it out. Yes, so we have a triangle there. So that would be half base times height. We have a triangle there, which would also be half base times height. And over here, we have a rectangle, which is length times breadth. So that one is going to be 12 times 1, 2, 3, 4, 5, 6, 7, 8. So that's 1896, is it right? Meters? Is this one 36? It's half of 6 times 12 is equal to 36 meters. And that one? 18 meters. So now we can go and say, this vehicle, we've got all the accelerations and the decelerations, traveled the total distance of 150 meters, which is 36 plus 96 plus 18. Could you follow me? Are you with me? Okay. Listen, if you've had these questions wrong, you must go back this afternoon and redo them. Okay? Right? No, you can't do it like that. No. No. It's a constant acceleration. The acceleration's not changing. So the gradient of the line must be constant. You understand? This is a velocity time graph, not a displacement time graph. You're confused between the two. If it was a displacement time graph, it will have a curve. But we've got a velocity time graph. Okay? Don't check that again. All right. Then you had number 5 as well. Is that right? Okay, number 5. The following graph shows the motion of a boy on a bicycle. Describe the motion fully. All right. Now, it looks like that. There. Oh, gosh. There and something like that. My graph is not accurate. Over here, we've got 10 seconds. Okay, this is time. And over there, we have 25. And over here, we have 30 seconds. Over here, we have got 20 meters per second. So now we have a velocity time graph. Now, can you see that he's accelerating? But that the acceleration is not constant, right? Can you see that? Now we've got the curved side. The gradient of this line is constantly changing. The acceleration is increasing. Yes, increasing acceleration. And then after 10 seconds, He travels at a speed of 20 meters per second for the next 15 seconds, after which slams on the brakes and decelerates rapidly in 5 seconds to come to rest. Are you with me? Yeah. All right. You've still got exercise? 1. Okay, let's go and do exercise 1. That's fine with me. Oh, shame. Exercise 1. An object moves initially with constant speed and then with constant acceleration. Which graph shows this motion? A speed time graph. So constant speed at first has to be horizontal, and then constant acceleration, it should have a gradient. So it would be graph B. All right? Number 2. An object moves with constant speed, but now be careful. What graphs have we got, Rain? Yes, a distance time graph. So what does constant speed for distance time look like? A line with a gradient. Okay, so the object moves at a constant speed for some time and then begins to accelerate. So we first need a line with a constant gradient, and then it's going to accelerate, it's going to curve, so it would have to be C. Okay, we can do 3 tomorrow.
ShopRite is your home of low prices this Christmas with unforgettable savings on everything you need. Stock up this festive season with great deals like 1.5 kilos of real good frozen mixed chicken portions, only $49.99, and 700 mils of all gold tomato sauce, just $26.99. Don't miss out on unforgettable savings at the home of low prices this Christmas. Only at ShopRite. Lower prices you can trust. Always.
Physics homework, exercise 1 on page 104. Let's quickly have a look. It wasn't very difficult, but it has got to do with speed and velocity and distance and displacement. All right. So a train begins a journey from a station and travels 60 kilometers. Come on, stop talking. Hey. All right. Travels at 60 kilometers in a time of 20 minutes. What is the average speed? Now, speed is, come on. What is going on here? There. Okay, so we have to work out the average speed. Speed, people, is distance divided by time. The distance was 60 kilometers. The time